Okay, class, so how did part 1 go? So today we are going to continue 4.3 of the optimization and modeling part 2. So as I said, I kind of break it into two parts. So part 1, part 2, and then after part 2, I put 2 questions that now I want you to try by yourself. So if you see what I try to make a logic here is before we haven't started textbook question yet. So I kind of prepare in part 1 so that you don't get too overwhelmed. And then now we're gonna start the part 2, example 1, 2, 3 from the textbook. I'm going to help you set up the function, and then I want you to do derivative and then get the answer, and then write it down the answer and compare your answer with the textbook, because these are exactly same question. I didn't change the number, so your answer should be exactly same, and the work is shown there too. So I want you to follow the work and do so. So let's look at appetizer 1, example 1 of the textbook examples, and now you hopefully we can all do this without any scary part. So what are the dimension of aluminum can that holds 40-inch cube of the juice that uses the least material? Least material, that's also showing as optimization, right? Assume that the can is cylindrical and it is tapped on both sides. Okay, if I can read this one. So input. So we have dealt with this one. What is the figure? The figure, I have cylinder can. I'm gonna call this as R as an input, and then output is going to be least amount of the material. Least material. What does that mean? Surface area, right? So input R, surface area, output, then function has to be written this form, and everything has to be written for R. So if you remember, that's H, and one information they gave it to me from the volume is equal to pi R squared times H in this case, which given as 40-inch cube. Then now let's study about what is our surface area. So it can be break into top, bottom, and then the side. So top is going to be pi R squared as area, and bottom is going to be same as a pi R squared, and then middle part is going to be the height is H, and then the width is going to be pi 2 pi R as the same as this radius, just remember that. So the rectangle area will be 2 pi R H. As you see, it's not as bad as the first time. So here I get 2 pi R squared plus 2 pi R H as my surface area. But as we mentioned, function, we cannot have the H here. So how we can rewrite this? 2 pi R squared plus 2 pi R H, we can rewrite as H is equal to 40 over pi R squared. So replace the number 40 over pi R squared. Then after simplify, we get 2 pi R squared plus 80 over R as my equation. So my function is going to be everything written in terms of R, and that's the relationship between radius and surface area. Okay, so for me, I will stop here, and I want you to use this function, and please take a derivative, show me all your work to earn the points, and read the textbook, and then compare the answer very end, and then show me that. Okay. Okay, now let's continue main dish 1. So did you understand what I meant as a 50% assist? So I'm only going to show you 50%, and with the book and all the things you have, just complete it and then compare the answer and upload it for me, and then I will grade all your derivative part. So this time, also another way is if you want to challenge yourself, then do it yourself, because 1 and 2 is a very familiar question. Do it yourself and then compare with me too. That will be really good way to learn. So Elena wants to get to the bus stop as quickly as possible. The bus stop is across the grassy field, 2,000 feet west, 2,000 feet west, and 600 feet north. So west from here to go west, and then that's the west, right? and then it's going to be 600 feet north of her starting point. Elena can walk along the edge of the park on the sidewalk at a speed of 6 feet per second. So her speed of the walk is 6 feet per second. And when she crossing the grass area, it's going to be 4 feet per second. So, which means there's a sidewalk, like concrete, here. And then here, this one is a grass. I'll use a green color. There's a grass area. So if you think about, you are walking here and then you want to get to the bus stop here, then you can actually, as we saw the example before, you can walk along this sidewalk and then grass area is going to be slower. Just think about when you walk to the beach, it's going to be slower than when you walk to the regular road. So this Elena gonna walk and then cross the field a little bit. Like if I used to walk all the way, like cross the field all the time as Skyline if you see me. But now let's try to see that what X value, how much has to get her? What path does she to the bus stop the fastest? So we want to find how far she has to walk and then cross the field. So let's try to see what's output. So our output is the fastest. Then what's going to be input? Input is going to be always x, right? So input is x, and this time we have to see the distance of. You could set it as a distance from here to here as x, but we saw the example that it would be easier to set a second case. So I actually gonna draw two diagrams, and then we are going to compare x says here, and then x says here. And then I want you guys to do derivative of both and then compare. So here's going to be x. So let's try first one. First case, if I set it as x, that's our first case we learned. And then this length will be 2000 minus x, right? So if I want to find the diagonal distance, this is going to be this square plus this square and square root. So 2000 minus x squared plus 600 square. That's the diagonal distance. So if I want to find fastest, that means we're talking about time. Then time, we write it as distance over rate. So function we want to find is a time, but in terms of x value. So here says time is distance over r. So the piece that I'm walking, this sidewalk, what is the time it takes? That's going to be x over speed as a 6 plus if you look at this distance is going to be 2000 minus x squared plus 600 squared over 4. So when I use the first x as this part, if I'm changing my x to the triangle, the reason I put here, because that will make my diagonal better, so that when I take derivative by hand, it can be easier. So I'm gonna set this one as x, then this piece will be 2000 minus x, right? And here to here, very confusing. And if I set this as x, this length is going to be same as 600. So the diagonal distance will be x squared plus 600 squared. Then I want to find the equation. T of x will be, again, distance of this one is 2000 minus x over rate as 6 will give me time it takes walking here, plus crossing the field, it will be x squared plus 600 squared over 4. So I want you to try derivative both ways. Both you can do it by hand without the calculator. Both you can do it by hand without the calculator. So I want you to do this side, I want you to do this side. And of course, after you get the x, you have to subtract from 2000 so that you can get the answer. You can get the same answer. So please do, and then upload this one. I feel that this one probably not gonna have a work, but also you can take number 15 or 16 of 4.3, number 16 or 15 of question of the textbook is actually taking derivative by hand, and I want you to try that. Okay, so that's about the, oh no, that's about the main dish. And function, you can have two cases. So that is case number 1, and then there's a case number 2, and both will give me the same answer after subtract. Okay. Okay, so how's the derivative going? Yeah, hopefully it gets faster whenever you do practice more. And dessert. So our dessert is going to be fresh new. And let's try to figure together. Here shows that curve y is equal to square root of x is equal to 9, y is equal to 0, and there's a rectangle with a vertical side that x is a and x is 9. Find the dimension of a rectangle having the maximum possible area. So let's try to draw first. We know the graph of this one, so square root of x is going to be like that. Okay, so I'm looking at square root of x, and x is equal to 9, so x is equal to 9, and then y is equal to 0, that's y is equal to 0, so we're talking about this figure here. Then here says the rectangle with the vertical size that x is equal to a. So think about x is equal to 2, then it's going to be 2 like this, right? And then x is equal to 9, so x is equal to 9. So we want to say this is the side, and then we want to figure out the area of this one, which will maximize. That will maximize. So as we saw, you can make your rectangle this way, you could make your rectangle this way. So do you see that all these 3 cases have a different area? So we want to see that what point will give me the best. Yeah, so when you do question with like this with a function given, don't forget that a lot of my students forget why we learn x and y. X means base, y means height, right? So don't forget, this is basically representing that length and this length. So now let's try to see what's the input. Probably it's going to be x, right? But we'll see what will be output. What is the output? Maximum area of a rectangle. So I know that's going to be length times width. Then I need to see that what I need to set as an x. So basically you can say that this is going to be, let's say I'm gonna put as x as a. Then what is going to be y? This coordinate will be, we can write it as x comma f of x, which is a comma f of a. So look at this rectangle carefully, class. All I need to find is, I need to find this length and that length. So think about it together with me. What should I set as an input? So input is going to be, do you see as a? Because I'm going to plug in a, right? Then this length is a. If you put it 3 comma 1, this is 3, that's 1. That means what is this length? How can I write this one? That will be 9 minus a. Everybody okay? Then what is the height? That's y. Y is the f of x. F of x is f of a. F of a is the square root of a. Everybody okay with that? So function I want to find is area, and then input has to be a. You can only use this input. Then since I'm looking for rectangle, I found the base and height. So 9 minus a times the square root of a. There you go. So that's the function I'm going to use, and then I'm going to stop here. I want you to take a derivative carefully and then find the answer, and then show me very end what you got. Also you can compare the answer with example 3. Okay, so this is it about optimization, and there are 2 questions that are very fresh, but I want you to graph and figure as you saw what I did. Just try to do that. That one you have to use distance formula. If you forgot the distance formula, that was x2 minus x1 squared plus y2 minus y1. So you will find the 2 points, and because they want to minimize the distance, and think about carefully how you can put that. Okay, so good luck and try. If you're having hard time, come visit me office hour on Sunday. Okay, see you later.